Okay, 4.2 specific heat capacity. Okay, got 5 learning standard that you need to power. First thing is you must know how to explain heat capacity, and then you must know how to define specific heat capacity of a material. Okay, heat capacity lain, specific heat capacity tu lain. Experiment to determine the specific heat capacity of water and aluminium. This one I think I forget to include in the notes, I think. Okay. Uh, Wait, let me check. I think I forget just now. Yeah, I forget to insert the experiment just now. Okay, never mind. Later I include it together. Then communicate to explain the application of specific heat capacity in daily life, material engineering and natural phenomena. Nanti kita tengok apa application dia. And solve problem. Kalau dia cakap problem solving tu calculation lah. Specific heat capacity using the formula Q equal to MC theta. Kena ingat formula ini because this formula you later need for your chemistry as well. Chemistry Form 5 Chapter 4. Okay, Chapter 4. Nanti akan diperlukan. Chapter 3 kot sekarang. KSSM Chapter 3, sorry. Okay, heat capacity tu apa dia? Capacity. Okay, capacity tu apa maksud? Kita tengok dulu apa tu capacity. We get the general idea of capacity. Capacity ni had muatan. Capacity. Contoh, kita ada satu bas kecil, kita ada satu bas besar. Kalau bas besar, dia boleh menampung 40 orang penumpang. Kalau bas kecil, dia boleh menumpang, let's say, half of it, 20 orang je. Jadi, ini bas A, ini bas B. Okay, I want to ask you, which bus can occupy passengers faster? A or B?
A.
A, sebab apa?
Sebab dia kecil.
Betul. Sebab dia kecil. And nak turunkan yang paling banyak penumpang pun, yang ni dia akan cepat kosong lah. I mean, cepat penuh dan cepat kosong dia adalah A. Compare to B, ini yang kita cakap capacity. Capacity tu, berapa banyak dia boleh menampung. You must get the idea of capacity first. Okay, now, let's see. Heat capacity. Heat capacity, dia letak C lah. Okay, big letter C. Quantity of heat energy needed to raise the temperature by 1 degree Celsius. Okay, quantity of heat energy needed to raise the temperature by 1 degree Celsius. For example, kita ada 2 kg air. Let's say air lah. So, to get from 30 to 31, kita nak naikkan 1 degree Celsius, we need 500 joule of energy. Okay, untuk meningkatkan temperature dia sebanyak 1 degree Celsius, kita perlukan 500 joule. 500 joule of heat energy. Okay, so that means kalau dia menerima 500 joule of heat energy, dia boleh menunjukkan perubahan temperature. So, itulah muatan dia. Muatan dia adalah 500 joule untuk menunjukkan perubahan. Okay, so dia punya formula adalah C equal to Q over theta. Okay, dia akan jadi macam ni. Q tu sebenarnya dia ada formula MC theta. So, MC theta over theta, theta cut. So, dia akan jadi MC lah. Baik, sebenarnya heat capacity tu not play really important role. The main thing we want to learn is a specific heat capacity. Okay, right. Yang ini dia nak bagi tahu je. When the mass increase, the heat capacity increase. Macam tadilah, kalau bas besar, capacity penumpang dia besar. Macam tu lah. Kalau mass increase, heat capacity increase. For example, soup in the larger bowl stay hotter longer. Okay, while in a small bowl it will stay for a short period of time. Kalau larger volume of water take longer time to boil, because greater the mass, greater the heat capacity. Okay, jadi Q ini adalah MC theta. Ini sepatutnya saya kena masuk dekat sini, tersilap masuk sana. Okay, specific heat capacity. Jadi mungkin kita samakan mass sekarang. Okay, tadi mass berbeza kan. Kalau mass meningkat, heat capacity dia meningkat. Okay, contoh kamu tengok. Mass meningkat, heat capacity dia meningkat. Sekarang kita andaikan, okay, let's say we have a 100 ml of water and 100 ml of oil. Kita ada water, kita ada oil. Dua-dua mass yang sama. Kalau mass dia sama, yang itu bukan lagi case heat capacity. Itu adalah case specific heat capacity. Sekarang mass dia sama. Tadi kita bincang, kalau mass meningkat, heat capacity meningkat. This one, the mass is the same. Tapi kalau kita panaskan, dua-dua serentak dengan api yang sama, which one will get hot faster? Water or oil? Yes, Afrina?
Oil.
Oil. Yes. Okay, oil ni dua-dua sama mass, tapi oil kenapa cepat panas? Okay, here is the thing. Setiap every type of object it have its own heat capacity, a very specific heat capacity. Capacity dia orang punya sendiri. Macam manusia, dia ada capacity dia berbeza kan, mengikut kemampuan. Macam itulah untuk all the object here, they have their own heat capacity. That is what we call specific heat capacity. So the specific heat capacity we represent as a small letter C. Kalau C dia lower, dia akan cepat panas. Temperature dia naik cepat. Temperature dia naik cepat. Kalau specific heat capacity dia besar, temperature dia, perubahan temperature dia kecil. Yang ni kita cakap perubahan temperature. I just put perubahan, better. The change in temperature is smaller. Okay, what is it mean actually? Okay, come here. This one just a general idea. Specific heat capacity. Specific heat capacity, small letter C, quantity of heat energy needed to raise the temperature by 1 kg only. To raise the temperature by 1 degree Celsius sahaja, itu sudah heat capacity. Kalau specific heat capacity, dia add the word 1 kg. Quantity of heat energy needed to raise the temperature of 1 kg substance by 1 degree Celsius. 1 kg substance, let's say we provide some heat. At how much heat energy needed for this 1 kg substance to raise its temperature from X degree Celsius to X plus 1 degree Celsius. Something like that. So the formula for the specific heat capacity, Q equal to MC theta. Remember, Q tu adalah heat energy. Heat energy. Jadi, joule dia punya simbol, unit dia. Mass multiply specific heat capacity multiply the change in theta. Change in theta maksudnya perubahan temperature. The big temperature minus the small temperature. Maximum temperature minus the minimum temperature. Jadi di sini kalau kita cakap high specific heat capacity, kan dia cakap heat capacity dia high. Jadi kalau kita nak panaskan, mestilah dia ambil masa yang lama. Sebab dia ada banyak ruangan untuk heat tu masuk. Jadi it will heat up slowly. And you want to cool down also, cannot cool down very fast. It cool down very slowly. So in short, when you have a high specific heat capacity, the temperature change is very small. That means you heat up or cool down, it will be very slow. Okay. Contoh dalam pen, kita ada satu pen ni, bahagian pemegang ni dia adalah high specific heat capacity. It heat up very slow down. It heat up very slow and it cool down also very slow. Tapi badan periuk tu, okay, it must have a low specific heat capacity. Macam minibus. Macam minibus dia, orang penuh bas tu dengan cepat. Sama juga, orang tu macam heat energy. Heat energy penuh aluminium, normally we made of aluminium, the badan dia. Okay, so the body of the pen have low specific heat capacity. So it heat up quickly or cool down also quickly. Okay. Jadi kalau low specific heat ni cepat panas, cepat sejuk. High specific heat capacity, lambat panas, lambat sejuk. Simple. Can understand so far?
Can, sir.
Okay, good. Next. Okay. Right. Next one. Relating electrical and heat energy. Not only electrical with heat energy, I also relate with kinetic energy, potential energy pun jadi juga. Boleh saja, sama saja. We use the what we call principle of conservation of energy that we learn in our form 3. Okay, now heat energy produced by electric heater will be absorbed by substance. For example, kamu ada satu cerek elektrik, the heat energy produced by this heating element will heat up the water because the heat energy supplied by the coil is absorbed by the water. Assume there is no loss of heat to the surrounding. The heat release by the heater we calculate like this. Quantity of heat released by the coil is equal to the quantity of the heat absorbed by the water. Formula ni penting sangat. Nanti saya nak buat apply in many different situation. Jadi, macam mana dia dapat PT ni? Do you know where the P and T come? Yes, Safrina?
P is power, T is time.
Yeah. எப்படி அந்த ஃபார்முலா வரும்? அது எப்படி Q-ஆ மாறுச்சு?
Q, heat supply.
Uh-huh.
I'm not sure.
Not sure. Okay, remember in form 3, we learned right. நம்ம என்ன படிச்சோம்? Power equal to energy over time. Correct?
Yes.
இது படிச்சிருப்போம். Powerனா energy over time. PET. Okay, இப்போ எனர்ஜியை வந்து நீனு சப்ஜெக்டா மாத்து. எனர்ஜியை சப்ஜெக்டா மாத்துனா PT.
PT.
அது ஹீட் எனர்ஜினால kita ganti dengan Q.
Oh.
You understand now? That's how the PT came from. And then Q absorb, just now we found out what? The amount of heat energy supplied or absorbed by a substance of 1 kg to raise its temperature by 1 degree Celsius is mc theta. Jadi formula dia PT equal to mc theta. Okay. Yang ini heat energy release equal to heat energy absorbed. Kadang-kadang kinetic energy can be transformed into heat energy as well. By the kinetic energy of a moving object is transformed to the heat energy when it brought to the rest. Kalau ada situasi macam tu, kamu tengok. Kita guna principle of conservation of energy, iaitu energy cannot be created, energy cannot be destroyed, but can change from one form to another form. So, dia mula-mula bergerak kan, dia jadi kinetic energy, dia punya form 3 ya, and then it is connected to the converted to the heat energy mc theta. Jadi dua-dua pun mass kan, sebenarnya kamu boleh potong. Nantilah. Sekarang for now you hafal this enough lah, but in the calculation you can simplify this something like this. Okay, and also for the potential energy ya, potential energy of a falling object, kadang-kadang kalau masa dia jatuh, it also converted to the heat energy. So mgh is the potential energy converted into heat energy mc theta. This m and this m you can potong, so gh equal to c theta. Okay, now full of calculations. Okay, ready with your calculator? You are going to calculate things for me. Okay, example 1. Okay, kita tengok. Immersion heater 100 watt 240 volt is to heat up 1 kg of aluminium block as shown in the diagram. After being heated for 5 minutes, the block increased its temperature by 33.3. Okay, now the first question. Calculate the heat energy supplied. Heat energy supplied.
PT.
So, PT, ya, PT sudah cukup. So, power dia adalah 100 watt. Time dia 5 minit tu kena tukar. Mesti dalam SI unit every time. So, 5 times 60 because we want the second. What is the answer?
30,000.
So, you cannot write 30,000. What you should write?
3 times 10 power of 5.
5 unit energy.
Joule.
Very good. Tak kisah apa jenis energy pun, dia punya unit mesti joule. Next, mc theta of the aluminium. We know that Q supplied, heat energy supplied is equal to heat energy absorbed. Q supplied is the PT. Q absorbed is the mc theta. So, your mc theta is equal to your power times time, which we just now calculate. 3 times 10 to the power of 5 joule. Got it?
Okay, sir.
Okay. Apa assumption yang kita kena buat masa kita nak andaikan Q supplied equal to Q absorbed? Very important question this one. Whatever we supply, all that much of energy is absorbed. Kita kena andaikan tiada haba yang lost to the surrounding. Kalau lost to the surrounding, apa yang dia supply tak sama dengan apa yang dia absorb, betul tak?
Betul.
Jadi there. Assuming there is no heat loss to the surrounding. Okay? So assumption dia, there is no heat loss to surrounding. Okay? Right. Dah?
Okay, sir. So for Q absorb, no need to do working, right?
Kejap. Saya punya laptop punya dia punya speaker tu tak clear. I cannot hear you. 1 minute.
Okay, sir.
Simple lah saya punya set. Okay. Is my voice is clear?
Yes.
Hello? Is my voice is clear?
Yes, sir.
Yes. What was your question?
For Q absorb, no need to do any working, right?
Yeah. If you already find out the PT.
Okay, sir.
Oh, wait. They are asking specific heat capacity, right?
Ha. Yes, yes.
Specific heat capacity tu C kan?
Ha.
Ya, saya tersilap baca tu. Okay. Ini Q saja. Okay, betul, betul, betul. Kejap, kejap. Saya dah ni. Salah ni. Okay, tak apa. Just don't erase everything. Just this part. Okay. Yeah, very good point you asking. Specific heat capacity yang dia tanya. Maksudnya C. Okay, jadi kita jadikan C tu sebagai subjek. M dengan theta kita letak di sini. Okay. PT kita dah calculate 3 times 10 to the power of 5. Letak atas. Mass dia adalah 1 kg of aluminium block. So letak 1. Dia cakap the temperature is increased by 33. Kalau increase to 33 kita tak boleh kira. Kalau increase by 33 dia sudah siap kira. The final temperature minus the initial temperature is equal to 33.3. Jadi kena understand the sentence. Increase by 33 and increase to 33 is different meaning. So 33.3, right? Okay. Right. What is the C?
C is 900.9.
900.9.
9.
Okay. What is the apa ni unit dia?
C.
Unit dia apa? Okay. Kalau tak tahu kita kena derive sendiri. Faham? Kalau tengok Q equal to MC theta kan? Okay. C jadi subjek. Q over M theta kan? Jadi Q ni apa unit dia? Joule.
Joule, kg.
kg kita naik atas negatif 1.
JK.
Degree Celsius negatif 1.
Wow.
Macam tu. Jangan pelik. Yang tu betul. Okay. J kg negatif 1. Degree Celsius negatif 1. Betul tu. Tak salah. Okay, kamu cuba tengok. J kg negatif 1. Degree Celsius negatif 1. Nampak tak sini? The specific heat capacity of the water. Nampak dia punya unit. Okay. Right. Untuk example 2. What does the statement specific heat capacity of titanium is 523 joule kg negative 1 kg negative 1 degree Celsius negative 1. Okay, nak jawab question ni. Macam mana?
523 joule kg negative 1 degree Celsius negative 1 is needed to raise the temperature of 1 kg of titanium by 1 degree Celsius.
Tapi yang permulaan tu you just mention 523 joule of heat energy sudah cukup.
Oh, okay.
Joule of heat energy, very good. Joule of heat energy is needed to increase the temperature. Jangan terus by 1 degree Celsius. Itu heat capacity saja. Dia tanya specific heat. Jadi by 1 kg titanium, very good. Of 1 kg titanium by 1 degree Celsius. Okay, next one. Wulan used 50 gram of metal spoon to stir her drink. If the temperature of the spoon increased from 30 to 45, calculate the heat capacity and the heat energy absorbed by the spoon. Okay. Baik, kita tengok heat capacity dia berapa. Heat capacity formula dia adalah big letter C equal to tadi kita tengok kan MC ya. Okay. Although it's not important but we need to know sometimes. The big letter C is just specific no. Heat capacity is equal to mass multiply the specific heat capacity. Okay. Big C equal to M small c. So the mass tu 50 gram kita kena tukar lah. Divide 1000, so 0.05 kg. And the specific heat capacity of the spoon is given in the question, 800. Jadi berapa?
40.
40. Okay, very good. Cuba ramalkan dia punya ni. Unit.
kg negatif
M tu apa dia? Kg kan?
kg.
Kg. C tu, ni dia ada kan? J, kg, negative 1, C, negative 1 kan? Kg, positive 1. Ini negative 1, dia cancel each other, faham? Sebab macam ni. Kg 1 darab dengan kg negative 1, apa kita buat? Kita tambahkan power dia.
Indices.
Indices, yes, good. So, plus minus 1, dia jadi apa?
Kosong.
Kosong tu 1 lah, kita tak mahu. So, joule, degree Celsius, negative 1. Tak perlu hafal, kita buat matematik saja. Okay, the next one. Calculate the heat capacity, dah buat. Calculate the heat energy absorbed. Heat energy absorbed is MC theta lah. Heat energy, MC theta. So the mass is 0.05. The theta, C is 800. Theta is final temperature or maximum temperature minus the minimum. 45 to 30. Tak boleh, heat energy ni tak boleh dapat dalam negatif. So we want positive value. Just take the big value minus the small value. What is the answer?
$600 joule.
Yes, good. 600 joule. Okay, very good. Now, the next one. A 3 kg ball of steel is placed in the boiling water. After it reached thermal equilibrium with the water, the ball was removed from the water and allowed to cool. Calculate the energy released by the ball to reach the temperature of 40 degrees Celsius. Given the specific heat capacity is 466. Heat energy release. Maksudnya dia tanya Q lah. Okay. Dia tanya Q lah. Q mass dah bagi. C dah ada. So this one you need to think. It is first of all dia cakap ini bukan theta. Theta tu mesti something minus something. So dia cakap it is dropped to 40 degrees Celsius, not by 40 degrees Celsius. So initially 3 kg ball you place in where? Boiling water. So 100 degrees Celsius. Because it already reached the thermal equilibrium with the water, proving that the steel ball initially 100 degrees Celsius. Sekarang dia reach 40. Yeah, that is the final temperature lah. Kita baru dapat semua information dia. Q equal to MC theta. Q ni bukan heat absorb saja, heat release pun sama je. Right, mass tu 3 kg, C tu 466. Theta is 100 minus 40. What joule?
Wait, answer.
Okay.
83,880 joule.
83,880 joule. Okay, good. Next question. Immersion heater 200 watt 240 volt is used to heat up 3 kg steel block if the specific heat capacity is 466. How long does it take? That means they're asking time. How long does it take to increase its temperature by 37 degrees Celsius? Okay, by, kalau dia cakap by 37 degrees Celsius, ingat kalau dia cakap by, itu straight away theta. Straight away theta, no need to think so much. Maksudnya dia sudah final minus initial dapat 37. Okay, so kalau dia ada guna perkataan by, straight away theta. Okay, dia yang ni kita guna formula PT equal to MC theta. So why we use PT equal to MC theta? Because the heat supplied by the heater is equal to the heat absorbed by the steel block. We assuming that. So the power is 200. The time we don't know. The mass is 3 kg. The C is 466. The theta straight away 37. So the T is equal to 3 times 466 times 37 divided by 200. So
Time is 258.63
258.63
second.
second. Good. Very good. Excellent. Next, kita tengok. Marlia want to drink warm water. Yang ni, mixing water. Mixing same substance. Yang ni dia dalam buku teks dia jarang bagi soalan macam ni semua. You need to know how to solve. Kalau mixing same substance macam mana, kalau mixing different substance macam mana, yang tu saya ada masuk. Nampak? Mixing two similar substance, kalau mixing two different substance macam mana? Okay, kita akan tengok satu persatu. Ini soalan kebat ada. Okay, specific capacity ni senang tapi kena berhati-hatilah. Okay, kita tengok. Marlia want to drink warm water, so she mix 0.5 kg boiling water with 0.3 kg of cold water at temperature 10 degrees Celsius. What is the final temperature of the mixture, assuming there is no heat loss to the surrounding? Okay, kita cuba bandingkan dia punya, kita cuba bayangkan dia punya ni, situasi. Okay, for example, we have a beaker of, let's say the hot water. Hot water is 0.5 kg. And then it is boiling water, right? So boiling water should be 100 degrees Celsius lah. And then you add on a few cup of water lah. Cold water. Okay, cold water is 0.3 kg and it is 10 degrees Celsius. The key point is both the substance are water, right? So you need to know that similar substance, kalau substance dia sama, heat capacity dia sama lah. Tak kisah dengan mass dia. So barang yang sama mestilah mempunyai heat capacity yang sama. Similar substance maksudnya same specific heat capacity. Lepas tu kita tengok. This one, okay. Now the cold water will absorb the heat. The hot water will release the heat. So the heat energy released by hot water should be equal to heat energy absorbed by cold water. That means M1 C theta 1. Why I put C only? Because similar substance, similar C. They cannot be C1 and C2. M2 C theta 2. So kita C dengan C kita potong. Sebab dua-dua C kan. Okay. Lepas tu mass by the hot water 0.5. Okay, theta dia we don't know. This 100 degree Celsius, from 100 degree Celsius dia akan berkurang kepada satu temperature yang kita kenali sebagai, let's say, T. So 100 minus T, let's say. Dia tanya final temperature of the mixing kan? Itulah T. Okay. Yang ni M2 dia adalah 0.3 kg. This one, you see, the okay, macam ni lah. Kalau kita mix dua benda ni kan, 100 degree Celsius dengan 10 degree Celsius, dia mesti ada satu temperature akhir dia, which is T lah. Okay, how we get this T? The 100 degree Celsius ni dia akan berkurang sampai T. The 10 degree Celsius dia akan meningkat sampai dapat T. Maksudnya, dekat hot water, the 100 must be decreased to become T. So 100 is greater than T. At here, 100 degree Celsius is greater than the T degree Celsius. That's why 100 minus T. Dekat sini, the final temperature must be greater than the 10 degree Celsius. Because heat will be absorbed by this 0.3 kg cold water. So, your T minus 10 degree Celsius. You faham tak? Kenapa saya guna?
Faham.
Faham. Okay, very good. Ramai yang dia tak boleh faham. Kalau hot water memanglah 100 tu besar, jadi 100 minus T. Kalau cold water tu 10 tu kecil, jadi T tu lagi besar. Jadi kita kena find the final temperature lah. Okay, so jadi kita nak buat apa? Kembang je lah. Easy. Kembang, lagi senang. So 50 minus 0.5 T equal to 0.3 T minus 3. Minus 3 kan, okay? Right. Jadi kita ambil yang kecil datang sini, 0.5 T datang sini, 50 plus 3 here. So 0.3 plus 0.5, 0.8 T equal to 53. So 53 divided by 0.8 equal to T. So what is the T?
66.25.
66.25 degrees Celsius. Bagus. Got any question? See the working and tell me.
Wait, I copy.
நீ மேல காப்பி பண்ணிட்டு என்கிட்ட சொல்லு, ஏதாவது ஒரு கட்டம் உனக்கு புரியலன்னா.
8 degrees Celsius negative 1.
Okay, bagus. 400 joule kg negative 1. Lepas tu degree Celsius negative 1. Bagus. Okay, tak macam tadi. Saya dah explain kan tadi. Okay. 200 gram of water, hot water of 80 degrees Celsius is mixed with 100 gram of cold water at 20 degrees Celsius. What is the final temperature? Okay, we let first. Let T be the final temperature of the water. Okay, now the 200 gram hot water, it will, from 80 degrees Celsius, it will turn to T degrees Celsius. This one by the hot water. Kalau cold water, it is from 20 degrees Celsius, it increase to T. Okay, right. Kita tengok. Di sini 80 is greater than T. Di sini T is greater than 20. Ingat tu sudah cukup. Okay. So hint, use the heat loss by the hot water is equal to heat gain by the cold water. Dah tahu kan method dia. Q heat energy lost by hot water is equal to Q absorbed by cold water. So kita tengok dua-dua pun air kan, benda yang sama. So M1 C theta 1 equal to M2 C theta 2. C dengan C kita potong sebab benda yang sama, similar substance means same specific heat capacity. So for the hot water 200 gram, kita tukar jadi 0.2 kg. Theta is from 80 it's dropped to 30. So 80 minus T. Untuk M2 it is 100 grams, so 0.1 kg. So the T is greater than 20, so T minus 20. Okay, lepas tu kita kembang. 0.2 times 80 is 16. Yeah, 16 and 0.2 T equal to 0.1 T minus, how much is this? 2. Okay, 1 over 10 divided 10, okay, 2. Okay, sekarang kita gerak je lah. 0.1 T plus 0.2 T. 16 plus 2. So 0.3 T equal to 18. So T equal to 18 divided by 0.3. Which you get?
60.
60 degrees Celsius. Okay, salin.
Okay, that's it.
Done. Okay, very good. Example 9. A 1.2 kilowatt immersion heater is to raise the temperature of 0.2 kg of water in a copper contain of mass 0.05 kg. Calculate the time taken. Okay, calculate the time taken so that the temperature of water and the container is increased by 20 degrees Celsius. Okay. It is given the specific heat capacity of the copper is 4000 copper 400, water is 4200. What they actually meant this? Oh, okay. Biasa je lah. I need to think first. A 1.2 kg immersion heater is used to raise the temperature of 0.2 kg. 0.2 kg of what? Of the water in copper container of mass. Calculate the time taken so the temperature of water and the container is increased by 20 degrees Celsius. Okay, but got two substance here. That's the problem here. Kalau dua substance, how I'm going to do that? Okay, wait, let me think first. Okay, a 1.2 immersion heater is used to raise the temperature of 0.2 kg in a copper container of a mass of 0.0. Dia bagi dua benda sekarang. Water and copper. The copper can lah. Okay, this like this lah. I think the immersion heater is used to raise the temperature. Okay, for example, the immersion heater ni dia ada dalam satu bekas. Okay. Bekas ni adalah copper can. Okay, copper can. This is the water. Calculate the time taken so that the temperature of water in the container is increased by 20 degrees Celsius. So this is the theta, definitely. So saya rasa macam ni lah. The heat energy supplied by the heater is equal to the heat energy absorbed by copper can and, or I put plus lah. Hilang mana? Kejap. Copper can plus heat energy absorbed by water. Logically, it should be in this way. Okay. Right. Q supplied by the heater always must be PT equal to M1 C1 theta 1 plus M2 C2 theta 2. Kenapa saya guna C1 and C2? Because both are different substance. One is copper can, one is water. Okay, kita cuba ganti dan tengok. Calculate the time taken je kan, dia tanya. Okay, power dia adalah 1.2 kilo. Kalau kamu tengok kilo, kilo tu apa value dia? Times 10 to the power of 3. Kan? Okay.
Dalam 1000.
Dalam 1000 boleh. Tapi you train your physics, kalau kilo, nampak kilo je 10 to the power of 3. Rather than you times 1000, I'll be very happy if you tell 10 to the power of 3. Okay. Because got reason for that. Like kadang-kadang kita keliru kena darab 1000 ke, kadang-kadang dia kena bahagi 1000. Jadi I will tell, if you see the kilo, just put 10 to the power of 3. Kalau tengok senti, 10 to the power of 2. Kalau tengok milli, 10 to the power of negative 3. Macam tu. Okay, mass 1. Mass 1, copper can punya mass adalah 0.05. Specific heat capacity of the copper, 400. Bracket. Theta is, okay, container, both also, I think both also having the same theta, 20 degrees Celsius. So it become theta only lah. Okay, it become theta only. ஏன்னா ரெண்டுமே வந்து ஒரே எனர்ஜி சேஞ்ச் தான் வருது. Plus M2 for water. Water dia adalah 0.2 kg. 4200 is the specific heat capacity. And the theta is 20. Okay, solve this. What do you get overall here? Right hand side.
$14.33.
14.33. Okay, I mean the total answer.
Total answer.
Okay, kejap. First, I want this answer. 0.05 times 400.
Oh, that one is 17,200.
200.
17,200.
Why I get 1260 only?
Oh,
Betul lah?
I check again.
Okay, check again. You kena tambah tau. Tengah-tengah dia kena tambah. Oh, wait. I pergi darat. Yeah, correct. 17,200 joule. Lepas tu kamu bahagi dengan 1.2 times 10 to the power of 3. Divide 1.2 times 10 to the power of 3. So you get 14,333. Banyak 14.333.
I get that one.
Okay, kejap 17,200 divided by 1.2 times 14.33. Yeah, correct. 14.33 second. Betul jawapan dia? Okay. Now, try to do example 10 and 11. Based on what I already teach you. Okay? Based on what I already teach you. I give you like 3 minutes for this, 3 minutes for this.
Yes, ma'am.
Okay. Try first. Boleh?
First one done. The second one,
Doing
I know. I'm not sure how to do it.
Okay.
ஏன்னா ரெண்டு மூணு இது வந்திருக்கு கப்பு வந்திருக்கு மேம்
கப்பு வேற வந்திருக்கா போச்சு போ சரி பார்க்கலாம் first one வந்து copper வந்து dipanaskan letak dalam air. So all the clue already given there. Okay. So temperature of the copper should be decreasing. Okay, a copper sphere of mass 500 gram is heated in a flame of Bunsen burner for several minutes before being immersed into the 2 kg of water of 30 degrees Celsius. The final temperature is now given ready. Calculate the temperature of the sphere before it was dropped. Okay. Tak kisahlah apa dia tanya. Kamu faham konsep, kamu kena tahu. The heat energy lost by the copper is equal to heat energy gain or absorbed by water. So M1 C1 theta 1 equal to M2 C2 theta 2. Both different object. So the mass of the copper is 500 grams, so 0.5. The specific heat capacity of the copper is 400. And the theta, the final temperature was 50, but we don't know the initial temperature. So it is the T minus 500. 500 pula, 50. Sebab dia cakap copper ni, it is initially T temperature, we don't know. It decreased to 50 degrees Celsius. Where T must be greater than 50. Remember that. Okay. And water pula, asal-asal dia 30 degrees Celsius. Lepas tu dia meningkat kepada 50 degrees Celsius. The final temperature must be same lah. Because both will achieve equilibrium. So here the 50 is greater than 30. Remember that. So is equal to mass of the water. Water is 2 kg. Specific capacity of the water is 4,200. Theta 2 is 50 minus 30. Okay, you solve this, then done. So no need to, okay, just put the T minus 50. Jangan kembang. You just write like this. 4,200, 50 minus 30. And then bring here 0.5 and 400. Dia daratkan kat sana. Kat sini bahagi. So T minus 50. What do you get?
Ada salah correct. ஆனால் T minus 50, 50 minus 30 நான் போடல. அது பார்க்கல அது இருக்கிறது.
நீ என்ன போட்ட 30 போட்டியா நேரா
30 போட்டேன்.
Oh, tak boleh. Final temperature kan 50. Ni எப்பவுமே யோசிக்கணும். அந்த theta வந்து something minus something. Unless kalau dia bagi by 30, by 20, straight away can put. Okay, right. Divided by 0.5 times 400. So, dapat 840. So, T is equal to 840 plus 50. So, you should be getting 890. Okay, 890 degrees Celsius. Right. Thank you. Okay. Buat dulu.
Sir, how to
Yeah.
know like T minus 50 எது minus எதுன்னு எப்படி தெரியும்?
Okay. Right. இப்போ காப்பர் வந்து சூடு காட்டுறாங்க, ரைட்டா? அப்போ டெம்பரேச்சர் அசால் dia adalah T di sini. எப்பவுமே நம்ம ஒன்று புரிஞ்சுக்கணும். தெர்மல் ஈக்குலிபிரியம் ரீச் பண்ணும்போது ஹாட் ஆப்ஜெக்டோட டெம்பரேச்சர் எப்பவுமே temperature of hot object will decrease. Temperature of cold object will increase. So, இப்போ original temperature is T. The final temperature is 50. So, T is greater than 50. From T, it is dropping to 50. So, அப்போ நம்ம இதோட theta கண்டுபிடிக்கும் போது, of course, you take the higher value minus the smaller value. So, T minus 50 வரும். இந்த இடத்துல asal dia 30 degree Celsius, cold object. Then, it is increased to 50. That means 50 degree Celsius greater than 30 ல, அதனால இதோட theta கண்டுபிடிக்கும் போது 50 minus 30. Can understand?
Okay, can sir.
Alright. So, or we want to create a conclusion also can here. So, மொத்தத்துல theta எப்படி கண்டுபிடிக்கலாம்னா, either temperature of hot object minus temperature of final temperature, final temperature also equal to temperature of final minus temperature of cold object. You understand? This one.
Yes, sir.
Either this cold object na இப்படி பாய்க்கணும். The position of T final will be different in hot object and cold object. Okay, next one. Next நம்ம பார்த்தோம்னா, what is the final temperature of coffee when the thermal equilibrium is reached? Auntie Susan pour 220 gram of coffee at 75 degrees Celsius. Okay, and 12 gram of milk at 10 degrees Celsius in a ceramic cup of mass 110 gram of which has been specified capacity. Ceramic cup வர இருக்கு. So what is the final temperature of the coffee? Kita ada coffee, kita ada milk. Lepas tu coffee, milk and also the cup, ceramic cup. So actually வந்து இதுல யார் பாலிங் பனாஸ்னு பார்த்தாக்கா coffee. Okay, milk and ceramic cup should be cold object. So kita ambil hot object saja asing. Okay. So the heat energy lost by coffee is equal to heat energy gained by cup plus heat energy gained by milk. Kalau dia ada gabungan, dia punya theta always same. Remember that? Here, the theta should be the same. 20 also here, 20 also here. So M1 C1 theta 1 equal to M2 C2 theta 2 plus M3 C3 theta 2. Notice that the theta should be same. Okay, dia tak akan berubah. Okay, so untuk coffee dulu. Coffee dia cakap 220 gram. So 0.22. And the specific capacity of the coffee is how much? Coffee and milk are the same of that water. Dia dah cakap coffee and milk are the same as the water. Jadi kita tahu water ni 4,200. So coffee maksudnya 4,200. Specific capacity. Milk pun 4,200. So 4,200. And the theta, coffee initially 75 degrees Celsius. It will drop to a final temperature of T. Dia tanya final temperature kan? T lah tu. So we take the hot object temperature minus the final temperature. Equal to, by the cup. Cup is 110 grams. So 0.11 kg. Cup punya specific capacity dia 1,100. And the theta is, okay, for the cup is, oh, they have the both different initial temperature. So I think we put theta 3 lah. Theta 3. Okay, theta 2 for the cup is initially 27 degrees Celsius because let's say room temperature, right? So அப்போ இது ரெண்டும் cold object தானே. cold objectக்கும் final temperatureம் பார்த்தாக்கா final temperature is greater than the temperature of the cold object. So T minus the cold object punya temperature which is 27 plus the heat gained by the milk. Milk வந்து எவ்வளோ milk 12 gram போட்டிருக்காங்க. 12 gramனா 0.012123. And then specific capacity of the milk is 4,200. Theta is T minus 10 degrees Celsius. Milk வந்து maybe fridge-ல இருந்து எடுத்திருக்காங்களா. Okay. So first of all இது நம்ம என்ன பண்ணலாம்னா நம்ம முதல்ல வந்து அதை simplify பண்ணுங்க எல்லாத்தையும். So this is one of the what longest question. 0.22 times 4,200. 924 75 minus T equal to 0.11 times 1100. 121 T minus 127 plus 0.012 times 4,200. 50.4 T minus 10. Okay, sekarang kita tak ada cara lain, kita kena kembang. 924 times 75. I dapat value yang besar, 69,300 minus 924T equals to 121T minus 121 darab 127. 15,367. Check for me, you also do your own calculation.
Okay, sir.
Because I'm not sure I'm doing the right. 50.4 T minus ni darab 10, sorry. So 504. So T tu semua kumpul di satu tempat. Kita kumpul di sini 101 T plus 924 T plus 50.4 T. Whole number all you bring one side. 69,300 minus akan jadi plus 15,367 plus 504. Aish. Okay, add them up. 100, 1095.4 T equal to, kadu adinga, 69,300 plus 15,367 plus 504. So it's all should be 85,171. So the T should be 85,171 divided by 1095.4. What do you get?
77.7. 77.8.
76 lah. Eh?
76.
77 point. Tapi dalam temperature yang kita guna dalam makmal, biasa dia satu tempat kan? Jadi 77.8. Sometimes you need to think like that also.
Okay.
So this is a logical value. Okay? So your coffee overall, your final temperature, everything is 77.8 degrees Celsius. Okay? Alright, I think kita sempat buat sampai calculation saja. I will message you for the next class. I think next Rabu is 22nd until 26th is off. Sorry.
Okay, sir.
Jadi kita akan tengoklah mana kita boleh buat, kita akan buat. Okay? Right. That's all. So no class this Saturday, Sunday, don't forget. And also to the Monday until Wednesday, I think. Wednesday. Yeah.
Okay, sir.
Okay. See you on next class. Take care. Bye.
Thank you, sir. Bye, sir.
Bye. Take care.